Hello, this is Tom from Every Step Calculus, everystepphysics.com, talking to you from San Diego, waiting for the NFL game to occur here at 12. Right now it's about 11 o'clock. This is a problem of calculus for the work of a spring. Normally this is totally a physics problem, which I have, of course, in my physics programs, all of the aspects of it where you're finding velocities and heights and spring constants and whatever, all the aspects of that, which are different formulas using algebra to switch everything around. The reason this work of a spring is included in calculus is that the integral of the Hooke's law, the function is equal to kx, which is k being the spring constant and x being the distance. And so when you integrate that, you come up with the formula for the work of a spring, and so therefore it's in the tests or homework of your calculus class. You'll notice here we have a force of 2 newtons, and it's compressing the spring, between 1 meter and 0.8. But notice we have the x values for distance in stretching and compressing springs, called the x factor, and this is the 1, 2, 3, 4 x's. So that's what we're looking for. And of course, work of a spring is in my menu. Press enter. I'm already at work of a spring to save time in the video here. And so the next menu that comes up, we're going to go down here to, this is the different work fields menus: work of a force field, work lifting a chain or cable, work lifting objects, work pumping oil, the work even of the shuttle going into orbit, etc. So we scroll down here. When you have an arrow here, like beside the 8 here, it means that there's more menu to go. So we're going to, we can go up with the arrow and go to the bottom of the menu. And here's work of a spring. We're going to press enter here to do that. And we're not launching an object, we're stretching a spring, compressing a spring, but so we can press 1 here. And now we're looking for what's given. And what's given is x1, x2, x3, x4, and then the force, which I've programmed, of course. That's the way I always program everything. Press enter. And we're going to enter the terms that are given. So here's force. We have to press alpha before you enter anything in any of my programs. Okay, so alpha 2 is the force. I show you what you've entered. You can change it if you want. I say it's okay. Here's the first distance we're talking about. That's the alpha 1. And meters, press number 4. I say it's okay. Here's the second one, which is alpha 0.8. Number 4. 0.8 meters, that's correct. Third distance is alpha 1.1. Number 4. That looks correct. The fourth one is alpha 1.5 meters, and that's correct. Now we subtract 1 minus 0.8 to get the actual distance compressed, which is 0.2 meters. We use that to find with Hooke's law, to find the spring constant. So we switch that around with algebra to 0.2 divided by 0.2 equals 10 Newton meters. That's the spring constant. And I make a note here that all displacements are relative to the actual spring's actual length, okay? Which of course here is 1. That's the length. It says natural length here is 1. And so the lower limit in setting up the integral is x3 minus x1, 1.1 minus 1, which is 0.1 meters. That's the lower limit. The upper limit is 1.5 minus 1, which is 0.5 meters. Notice how neat this is. You're writing this all on your paper so you can show the teacher you know you're a genius at this stuff and how you got these various things. And this is not easy. If you don't have this program, if you're trying to remember this in a test, you're in big trouble. So we set up the definite integral here. This is a definite integral because it has a range, right? So work is equal to the integral of the Hooke's law, kx dx, with respect to x. That's what the dx is for, obviously. And so then we're going to integrate here now. We integrate it. Notice that the constants come out of the k comes out, which is here, the 10 Newton meters, out of an integral. All constants come out of the integral. And then you integrate what's left, which is x. So it becomes x squared, and then of course you divide by this exponent here, which is out here already, over the range of 0.1, 0.5. Now we do the upper range minus the lower range here. Come up here where this is what that 0.5 squared minus 0.1 squared is 0.24. When you multiply 1/2, 10 times 0.24, you get 1.2 joules, which is the answer. That's what the work equals. Pretty neat, huh? Go to my site, Every Step Calculus or Every Step Physics, and pass your classes, or learn a lot about how to do these problems without a lot of study. These are the best programs ever in this amazing calculator of the Titanium Calculator. And I'm old enough to actually bought the first really computer, Osborne computer, which I programmed and did all this stuff, started to do it. And then of course when I was in calculus class we had to buy the TI92 calculator, which was brand new. It's big, larger calculator with a keyboard, which is, and then the TI92 Plus is even better than the Titanium, but they don't make that anymore. And then they even class the Titanium here now, or not really outclassed it, because this is the best calculator ever, but they have the new ones coming out which don't have the programming capabilities anymore and stuff like that, or different systems which all suck compared to this. So you'd throw away your calculus books or physics books because everything's in here. Over 550 programs in here, all designed to help you pass calculus. And then I'll help you too if you call me, or call me on the phone, or you can email me and I'll help you. Send me quizzes and I'll show you how my programs work on the quizzes for your calculus or physics tests, whatever. Say you have a good one, okay? Happy New Year.